Okay, before I start my talk, let me ask you some traditional questions. First of all, who needs Windows testing? Raise your hand. Selenium testing under Windows. Half of people approximately, okay. And who is from time to time suffering from various tests, instability under Windows, losing focus, and so on? Raise your hand. Almost the same people. Okay. And who knows what Selenoid is? Probably try to use it. Anyone? One, two, several persons. Great. Let's move to the talk then. My name is Ivan Krutov, and today I'm going to tell you why Windows browsers should be packed to Docker images and how to do that. A few words about me. Being a software developer during the last decade, my main experience is related to Java and Golang programming languages. My main activities during the last 5 years are called with a buzzword, DevOps. That means that I'm creating and maintaining various infrastructure. And one of the biggest products I'm working on is a big Selenium cluster. So how big is this cluster? Compared to a typical Selenium grid with 50 browsers and executing 10,000 browser sessions per day, my cluster has more than 5,000 browsers running in parallel and executing more than 2.5 million browser sessions per day. These browsers are distributed across 5 data centers. The average load on the cluster is about 4,000 requests per second. The traffic is more than 2 gigabits per second, and this cluster is certainly working all the time. This cluster has all popular browsers and platforms, including last 10 versions of Firefox, Chrome, Opera, all versions of Internet Explorer, Microsoft Edge, Android emulators running on real hardware servers, iOS simulators running on Mac Minis, and for some teams we also have real devices, phones and tablet PCs connected to the same cluster. Finally, some of you could be using one of the tools we are working on, including Selenoid, an open source Selenium protocol implementation running browsers and Android emulators in Docker containers, Moon doing the same stuff in a Kubernetes cluster, and a new thing called Browsers, which is an online testing platform similar to Sauce Labs, Browser Stack, and Friends. So if you have any questions related to these tools, you can ask me right after the talk. So why is it so important to do Selenium testing under Windows? First of all, in 2019, Windows is still the leading desktop operating system with from 75 to 80% of the market share. And you simply can't ignore testing your web application under Windows. Then, the most popular Windows browsers are Firefox, Chrome, Opera, Internet Explorer, and Microsoft Edge. While the first three have their Linux versions and thus can be easily packed to Docker images, Internet Explorer and Microsoft Edge are nailed down to Windows. In big companies, especially banks and governmental organizations, there are a lot of legacy web applications requiring ActiveX, using ActiveX and similar technologies, and thus strictly requiring Internet Explorer to test them. Finally, even mainstream browsers like Firefox, Chrome, and Opera can work differently under Windows and under Linux. Windows and Linux have different font sets and anti-aliasing algorithms, and this can lead to a bit different rendering of the same web pages under Linux and under Windows. And front-end developers should certainly take this into consideration. Who already tried? I already asked. Who already tried doing Selenium testing under Windows? Raise your hand. Half of people. Was it easy? I think no. So Windows is the most needed and the most complicated Selenium testing platform. First of all, let's take a look at a traditional Selenium testing architecture. I think most of you have already seen this picture a lot of times. It consists of a well-known web server implementing Selenium API and handling test commands, a browser installed in the operating system, and between them we have a WebDriver, a standalone binary knowing browser internals and translating test commands to browser-specific commands. Being so simple, this architecture is unfortunately followed by a long tail of issues. Browsers very often have memory leaks, and they also clutter your hard disk with cache and cookies like the following. So, you know, Pac-Man. It is impossible to run your tests in two different versions of Microsoft Edge or Internet Explorer on the same machine. These browsers are usually updated using the Windows Updates tool, and a newer version completely removes an older one. So this is impossible. That's a shame, but in 2019 it is still impossible to run two parallel Microsoft Edge Selenium sessions on the same machine. And this issue exists more than 3 years. Here's one of the last comments on this issue, the Microsoft web page. Finally, in order to avoid annoying window focus issues when running several Selenium sessions in parallel under Windows, you have to use sophisticated process isolation techniques like launching every browser session in a separate virtual desktop. And for Internet Explorer, you also have to launch every session under a separate user account to isolate browser cache. So all these issues make traditional Selenium testing under Windows a very, very, very expensive thing. 2 years ago, I was already speaking about the similar issues in the mainstream browsers like Firefox, Chrome, and Opera. Most of these issues are caused by the lack of isolation between browser processes. An elegant solution of these issues is running every browser session in a separate container. And the most popular container platform nowadays is called Docker. Let's now remember that Selenium architecture under Windows and under Linux is the same. So the only problem we have to resolve is how to run graphical Windows applications inside Docker containers. All Docker versions support running only Linux binaries inside the containers. Docker for Windows, however, has support for running command line Windows applications. But no Docker version can run graphical Windows applications inside containers. In order to understand how this problem could be solved, let's take a look at another complicated Selenium testing platform called Android. So those of you who are already working with mobile automation should know about Android emulators. An Android emulator is a desktop application showing you just the same screen as the real device and allowing to test mobile applications without buying real phones and tablet PCs. And a year ago on SeleniumConf India, I have shown ready-to-use Docker images with Android emulators inside. Every such image contains inside an Android emulator and Appium, an open source tool delivering Selenium support to mobile platforms. The most important fact about Android emulator is that internally an emulator is a virtual machine using a KVM to run, just to work. And this leads to a very simple idea. We can use just the same virtualization technique to run Windows-only browsers inside Linux containers. And here is how it should work. So we launch a standard Linux container, and inside this container we start a standard virtual machine having required browser version and compatible WebDriver binary. The WebDriver binary is then forwarded outside of the virtual machine. And having a Selenium API listening inside a Docker container, we can then we can provide the end user access to this API using standard Docker features like port forwarding. A build procedure for such images usually consists of 3 main steps. So first of all, that's an ugly bug in my software. First of all, we take an installation disk image with Windows and launch a virtual machine using this installation CD, and then follow Windows installation steps. Having Windows installed, we do additional configuration inside the virtual machine, like changing browser settings, editing registry entries, turning off anti-aliasing, and so on and so forth. On this stage, we also download to the virtual machine a compatible WebDriver binary version. On the second stage, we start the WebDriver inside the virtual machine and then create so-called virtual machine memory snapshot. By default, a virtual machine is started during approximately 1 minute, and this is too slow to work, to have efficient Selenium testing. So what we are doing, we are taking the full memory contents and save all the memory contents to a file on the disk. And this file is then used to quickly restore the virtual machine seconds. This is done in during several seconds. The same magic happens when you start your personal computer from the hibernation state. So having a virtual machine memory snapshot saved to a disk, we stop the virtual machine and find 2 files on the disk. The first one is the virtual machine disk image file, and the second one is just saved memory, virtual machine memory image file. So on the third step, we already have these 2 files and are ready to create a Docker image with Windows inside. We take a standard Docker image, copy both files inside this image, and use a headless X server such as XVFB in order to be able to launch this virtual machine without real display in headless mode. So let's now see how it works in real life. Just a demonstration. Okay. We'll see. Okay, first of all, I'm showing here quickly a repository like this. There will be a full URL on the last slide. So this repository is a full instruction how to build your images with Windows-only browsers. During the previous talk, Bonnie has already said that we cannot publish ready-to-use images with Windows just because of the license limitations. So you have to build such images yourself. Okay. Okay. So here I'm just showing the contents of this repository, so you could understand that this is a straightforward instruction having some preparative steps, a Windows installation procedure with all the screenshots provided here. Then we have a step when we are copying the WebDriver binary inside the virtual machine. Then we are taking the memory snapshot to a file And finally, we are building the Docker image inside, having the virtual machine inside this image. So having a ready-to-use image, we can now launch it on any Linux server. So here I'm having a recent Docker version on a Linux server. I'm showing that I'm having a recent Ubuntu version and a recent Linux kernel version like 4.15. And now I can use a very standard Docker command to, just let me pause a bit, to launch this image. So I'm just specifying the image name, the container name, which is important. I'm specifying the privileged flag and several port forwarding flags. So that's a very, very standard command for those who are working with Docker. And having done this, I'm getting a container running on a Linux server. Okay, so here is a running container with Microsoft Edge inside, and we can now go inside the container using first of all, we can check that this container has a Selenium API listening inside it. So we do an HTTP request to status API, and we are seeing that there is a WebDriver inside, so we can launch our test just against this container. And then we are going inside the container to see which processes are running inside it. So here we have three main processes. The first one is called XVFB, that's a headless X server. Then we have Camo, that's a virtual machine process. And the third process is X11 VNC, that's a VNC server, in order to provide VNC access, VNC screen access. So here I'm showing that knowing the host name of this of the machine where the container is actually running, here I'm using some internal network host names. We can easily access this container using standard VNC client. So like I'm typing the password, in that case it's just Selenoid, and I'm seeing a real Windows running, a real copy of Windows running inside Linux Docker container. So here is the real Windows. I can do any operations using VNC, like opening Windows Explorer, navigating through the folders, and so on and so forth. So now I'm showing that I can run a test just against this running container. So here, as always, I'm showing very standard Java test using the standard Java Selenium bindings and doing very, very simple stuff. It opens the page duckduckgo.com. Who knows duckduckgo.com? Raise your hand. Several persons. DuckDuckGo.com is a search engine like Google or, I don't know, Bing, but this engine is anonymous. It doesn't track your activities and so on. It opens the DuckDuckGo.com page, types the words Selenium in the search string and presses enter button and just takes the screenshot of what's happening inside the browser. So in this example, I'm using a new style Selenium options to launch Microsoft Edge inside container, and and I'm typing the word Selenium and pressing enter. So currently I'm launching this test in debug mode because I have a breakpoint in the code. So first of all, you are seeing that the session is started rather fast. Approximately takes from 10 to 15 seconds to start a session, like in a normal Selenium installation. So that's the real execution speed, not the accelerated video. So we get our code to reach this breakpoint, and we are seeing the Microsoft Edge window, which is open inside this Linux Docker container. We continue our test execution, and we are seeing our test executing inside this Docker container under Linux. So here it is. Okay, that should be it. Sorry. Okay, that was simple and impressive, right? But playing with Docker images manually doesn't solve efficient Selenium testing problems. We need some launcher being able to run several Docker images in parallel for every test. And such launcher exists and is called Selenoid. So Selenoid is another implementation of the well-known Selenium protocol. It's implemented in the Golang language and is distributed as a small standalone binary that you can run on any supported architecture. And Selenoid is usually launched with a configuration file specifying which browser versions are available and which Docker image should be run for every desired browser version. And this simple approach allows you to run several versions of the same Internet Explorer or Microsoft Edge on the same machine. So, which is more important, you can see the live browser screen out of the box. So as you have already seen, every virtual machine has a VNC port listening inside the virtual machine. And Selenoid can capture this traffic and just proxy this traffic and give the access to the traffic from the outside using the WebSockets. A standalone graphical user interface for Selenoid called Selenoid UI is then able to read this traffic and visualize it in browser. I will show this a bit later. In some cases, it is more useful to have the full test execution video instead of looking at the the live browser screen. And this is also supported out of the box. This works by launching a standalone, a separate container with video recording software called FFmpeg, which connects to a running browser container using X protocol and starts to capture the entire screen contents. All these contents are saved to a file on the hard disk when your Selenium session ends. So let's now see how it works in the wild. So first of all, I'm showing here how to start Selenoid as a binary. So as I said, Selenoid is not a Java application. It doesn't require any external dependencies, just a binary. You can download you can either compile yourself from the sources, it's open source, or you can download an already compiled binary from the GitHub releases page. So that's just a Linux executable. Having such executable, we also need to have a JSON configuration file to work with Windows browsers. So here is an example configuration file to run a Microsoft Edge image. It contains very simple information like browser name, default version, and available versions list. Like here we have Microsoft Edge 18. And we specify that we are running a Docker image like this to run the tests inside for this browser. So having these two files, we are ready to launch our server and to be able to run our tests against it. Okay, so we are launching the binary like this. We can specify, for example, any custom port to listen on, and a configuration file that I have just shown to you. So we get a Selenium compatible API. So we can just run the same test against Selenoid. First of all, I'm showing how the video recording is working. This works by adding by adding one more capability called enable video. And when you add this capability and run just the same test, you will be able to see a fully recorded file just accessible in your browser. So that's already also the real session execution speed. It takes approximately 25 seconds to launch a browser, open the page, do some actions, and take the screenshots. So rather fast, 26 seconds. And after executing the test, we are able to open the Selenoid API, just called video API, click on the file, on the recorded file corresponding to the Selenium session ID, and see the same session being executed inside Windows. So that's the browser, launching, that's the duckduckgo.com, Selenium word typed, and that's it. And finally, I'm showing how you could debug your tests, because sometimes you may need to debug your tests, like placing breakpoints on your code and so on. So here I'm showing one more binary called a graphical user interface for Selenoid called Selenoid UI. This is also a standard Linux binary. You can launch like this. You can also launch it by specifying any custom listening port. Default port is 8080, so you can just use the default settings. Here I'm showing how to launch it with any custom listening port. And here I'm also specifying an access URL to Selenoid in order to be able to get the status of running sessions. So having this binary running on the server, we can now launch our tests in debug mode by adding one more capability like this, enable VNC. And we should also add a breakpoint where we need to have it. So we launch a session, wait for our program to reach this breakpoint in the code, and we will now be able to see our browser session being executed inside the browser window. So from 10 to 50 seconds to start the session. The breakpoint is now activated. We can now switch to a Selenoid UI. So here we are seeing all running browser statistics as well as buttons for every running browser sessions. So by clicking on a button, we are now able to see just the same Selenium session being shown inside your browser. So you can have your Selenoid running somewhere in the data center, and you can see all the sessions being working on your personal computer. So here we are running just the same test. Now if we resume the test, we will see just the same thing for the third time, just the same test. Okay. So you now see that efficient Selenium testing problem is not efficient Selenium testing under Windows is not a science fiction in 2019, and it's doable. But even this approach has some limitations. I already said that we are running a virtual machine inside a Docker container, and to work with virtual machines, your server should support so-called kernel-based virtualization, or just KVM. Such feature is supported on the majority of real hardware servers, as well as on some types of particular types of virtual machines having nested virtualization support. So clouds like Google Cloud or Azure, I think, should support this. Every container with Windows inside consumes approximately 2 CPUs and 2 gigabytes of memory. That is to say, 2 times more than a standard Linux container with a browser inside. Another thing you should take into consideration is how many licenses you have to purchase in order to run Windows. Contrarily to Linux, Windows is a commercial operating system requiring a license to run it. So far as we are running a virtual machine inside a Docker container, a special type of the license called Virtual Desktop Access, or just VDA, could be purchased. Every such license allows to run up to 4 virtual machines, that is to say up to 4 containers, Docker containers with Windows. And to conclude, you now see that efficient Selenium testing is possible in 2019. And this problem of the century is now resolved. Just take this solution and make your Selenium life easier. And on the second slide, as usually, I have all the references, so I can take the photos. Here I have GitHub repositories for Selenoid, for these instructions on how to build Windows images, our Twitter account, our Telegram support channel, our website where you can find some interesting articles about efficient Selenium testing. And finally here I have a shortened URL for our YouTube channel where we are usually publishing all the conference videos as well as demonstration videos. So all the videos I have shown today will also be published there. So thank you for your attention, and you can now ask your questions. By the way, before you start to ask some questions, I hope I have some motivation. So everybody who asks a question, we will just get a sweet stuff for the brain. Because you should be tired, that's the second day of the conference. Any questions? Oh, there's a question there.
Great talk, thank you. I have a question about running this in the cloud, given that you probably have to run the containers in privileged mode, as well as have QEMM installed, and how you see that playing out at scale using something like Azure.
I don't have experience with Azure. We have tried to run this in under Google Cloud. So as I said, no, I didn't said. We usually recommend running this on the real hardware just because on the cloud platforms it is slightly slower because of the nesting of the virtualization. So it will work, but the session startup time could be like a minute or so. Okay. So this is doable. Anyway, this is doable, but it's slightly slower. So we usually recommend running on the hardware.
Okay, thank you.
Just a gift for a question. How are you? Any more?
Hi. Thank you for your talk. So I'm already familiar with Selenoid and Moon, and I have a question. Microsoft provided its virtual machine for testing.
Yep.
Officially.
Yep. So
maybe I can use these machines for that virtualization?
That's a difficult question because, you know, so far as I know, according to Microsoft licenses, these images are for personal use only. So I think if you want to use them in your company to run tests of different users, that's not okay.
Okay. Because
so I don't think you have the right to do that. I don't think so.
Okay,
I don't think
see.
So
Thanks.
for personal usage, I think you can.
Yeah, of course, because they say they give the virtual machine to you to test if it works on Microsoft Edge.
Anyway, I would consult with your legal department in order to avoid any issues with Microsoft. You know. Any more questions? No. Oh, there's a question here. Oh.
You mentioned 2 gigs of RAM, 2 CPUs allocated.
Yep.
Is that the minimum requirements you would say per container, or could you see them needing more for maybe resource-intensive
Really
websites?
It really depends. For example, we don't have a lot of statistics about Windows containers because this approach is rather recent. But for example, if we compare them to Linux containers, by default, we usually say to our users to start by 1 CPU core and 1 gigabyte of memory. And how much memory, how much CPU it would consume depends on the application you are testing. So there are some, I don't know, big applications with a lot of JavaScript inside that should be loaded to the memory, and they are consuming a lot of memory. There are some small websites, and in that case, for example, half of CPU core and 500 megabytes of memory can be sufficient. And the same stuff is applicable to these Docker images. So they can consume 2 cores, they can consume 1 core, it depends.
Okay, great. Yeah, I was just thinking how many resources I would need from like a Kubernetes cluster. Okay,
it really depends. But,
thank you.
In average, 2 CPU cores should be sufficient.
Thanks.
There was a question here.
Oh, sorry.
I said. I will give you stickers.
So my question was, how do you manage version control? Because I imagine, for example, in my company, we constantly update our images with, latest browsers, latest web drivers, everything basically. We try to keep on top of it. So do you need to do all of those steps again, where you install, Windows and to take the new snapshot of the new system?
No, in that case, you can first of all prepare some base. Just take a Windows installation CD, run a virtual machine, do all the installation steps, blah blah blah, and take a snapshot of the disk of this virtual machine. Then you can launch when you update the browser version. Then you launch a ready-to-use snapshot. Only do apply this difference by installing a new browser version and create the new memory snapshot and the new disk snapshot. That's it. Right. So certainly you don't need to do all the steps from scratch.
Okay, cool. Thanks.
There's a question here on the first row.
Oh, yeah.
Thank you for your talk. You mentioned that you built a huge grid that consists of 5,000 browsers.
Yep.
So do all of these 5,000 browsers connect to one hub, or you built?
That's not a grid. It doesn't use Selenium grid architecture at all. You can see my previous talks on the previous Selenium conferences. We also have, how do I say, another open source tools we are speaking during, I would say, 4 years already, which delivers the load balancing for Selenium cluster. So if you wish, I can talk a bit more in detail just during the break.
Sure, that would be great. Thank you.
So there are some talks. For example, on SeleniumConf Berlin, I was already speaking about this 2 years ago.
Thank you.
The question?
That's it.
The last one? No? Looks on. Thank you.
Thank you so much.